Let's now look into the Jcd program, which is an iterative version that we are going to see. So we all know the Euclid's algorithm, which you should have studied in your math in your school. So basically, this is a program which implements the Euclid algorithm. So given m and n, so it will continuously keep assigning m modulo n and then n. They are the two new m and n's, right? So it will repeat this particular process until the second number becomes 0. Once the second number becomes 0, then you will return the first number. At the point when second number becomes 0, that's when you will do that. Okay. So here we are taking input, and then we are calling the GCD function, which does that and then returns that particular m value. And then finally we are printing it. So let's look at how the lower level instructions come out of these. Okay. So if you look at the initial statements, you have A, B, D. They are global variables. They need to be given space, and then finally A and B needs to be coming from the user, and that's why these statements are existing. So the next thing would be to give a call to GCD. What would that do? The GCD call will make an instruction function called fcall to GCD, and once that is done, then we need to set up things, right? So if you look at the GCD function, there are parameters m and n, and there are local variable r, and there is also a 0 which needs to be stored in a temporary variable. So that is this temp. So m, n, r and temp, the space is made for them. So you push onto the stack one by one, and then you pass the a and b value to m and n respectively. So from data segment to stack segment, these will be copied. Okay, it's basically from one part of the memory to another part of the memory. Okay, so having done that, now we'll be in a position to enter GCD and do the computation. Let's look at the GCD computation. So GCD computation is a long computation. Let's break it down and then see it in parts. So when the GCD is being called, so you know these are the instructions that needs to execute. There is a while loop, and then once the while loop finishes, you are returning this m. So this is what you are doing, right? So basically, if you look at the initial steps would be that no, you do this particular operation, right? You need to check this. So because there is a loop which is at the starting point of the function. Okay, so the loop you may have to come back more than once, right? So you need to keep repeating. So therefore you mark your point saying that label L1 before you start the loop, and then you do the operations involved in the loop, and 0 has to be copied to temp so that it can be loaded onto a register at this particular point. And similarly m and n are being used, so m and n also have to be loaded. So this is what you are typically doing. Now what happens? Now once all the things are loaded, now you can check whether n is not equal to 0, which indirectly maps to whether register 2 and R6 register 6, they are not equal. Okay, if they are not equal, then I'm ready to execute the loop. Okay, that's what you are trying to say. Now at this point of time, you might have this thing, this possibility that this can be false. N not equal to 0 could be false. Okay, so that is basically n would be 0. So if such a thing happens, then what you want to do, you want to go out of the loop, and you don't want to get stuck in the group, and you want to go out of the loop. So therefore we need to have a marking position. So we are saying label L2 so that you can redirect. If it is a false, go to L2, don't do any of the part which is specified in the body of the while loop. So this is where you go, and finally you have to return that m, right? If you have to return that m. So let's look at this. Uh, Now if it is true, then your statements would be executed. So you have to do the remainder operation. you have to do the remainder operation, and then you have to do the assignment. N becomes M, and then N becomes R. So this is the kind of assignment that you want to do, and that's what is being done by this store and load operations. And finally, because it is true, then you want to go back to L1 and then repeat this loop. Okay, so this is the both the entry and exit criteria for a loop. Okay, so that's basically the um, um, point. So whenever you go into a loop, it's make sure that you come back to this particular point. So that is captured by label L1. And when you want to go out of the loop, then this is the exit point, which is captured by label L2. And this is what you typically do. Though it's a long series of instructions, they are pretty straightforward for you to understand. Okay, and then once this part is done, then you return from GCD function. So then you come back to this particular point. Now you pop out all the things that you pushed inside the stack, because the function is done. You no more need these variables, so you just push it back. Okay, pop out of them. So in the reverse order, we would do temp, R, N, and M. They are one by one come out of the stack. So um, and then finally um, you say print once the GCD is done, and D is being set here, so you can come out of it and then say you can print. So this is the overall operation of a GCD function in an iterative manner. Okay, so though the instruction seems to be really pretty large for a program like this, but you can get a taste of how it's going to be executed by the hardware and what are the nitty-gritties involved in these things. Because when you write a program, if you want to write it correctly and you want to write optimally, the understanding of this is pretty much necessary. So why you should not use too many variables, and these are some of the things, why you should not make unnecessary function calls. Now you should learn to write programs pretty tight, and understanding and how the hardware sees it, even though this is a very high level view, but still it gives you enough foothold of how the hardware deals with the instructions. Having gone through the program and its equivalent low level instructions, which is a long series of instructions, now you are in a position to try this slowly to understand how it's being executed, and you can just get started with from here. Okay, and we will leave it at that.